Hey, it's Martin Griffiths, co-founder of Metis Automation, helping manufacturers to visualize and control the products in their factory. And in this video, I'm going to talk about a method of how to detect and prevent mistakes in your manufacturing process. And I spent the first 10 years of my career as a mechanical engineer and a manufacturing manager in automotive companies. And then since starting Metis Automation, in 100 projects, we've helped manufacturers to improve their manufacturing processes. So here I'm aiming to take some of what I've learned, some of my expertise, and to share that with you in a kind of a systematic way of how you can address this issue. Be sure to stay to the end of the video. We've got some templates and tools that we use, that we've used in lots of projects that I think will be helpful for you to use. So, preventable mistakes in the manufacturing process. They're frustrating, they're annoying for your customer, but on the flip side, they're quite low-hanging fruit for business improvement. And by approaching it with a system and a number of steps, you can create quite a big impact quite quickly. So, what are the steps? Step number one: build a team to address the issue. So you've identified. Take the situation that you've identified a number of mistakes that keep happening in your factory, or you've had some returns from a customer and you really need to resolve the mistakes that cause those returns. By building a team involving people like a customer representative, someone from product design, someone from manufacturing operations, and ideally someone from quality if you've got a quality department, that's going to make sure that whatever solution you come up with, it makes sure the customer gets what they want, it makes sure it's not going to affect the product performance, and by having manufacturing and quality involved, it makes sure that you're going to get buy-in from the shop floor and you come up with a solution that will actually work out in the factory. Okay, so step number two, you've got your team, it's to identify the risks. So any possible mistake that could happen, you need to understand what knock-on effect that can have in your product and to the fit, form and function of it when it gets used, or maybe the safety of it to the people around the product. And then by understanding the risks, you need to know what level of things you have to do to reduce those risks to an acceptable level. Use a tool like a failure mode and effects analysis, which I can share a template of later on. Sit down in a room and bounce around ideas, come up with the things that could go wrong and think through, from past experience, from discussions with your customers of what could happen, and try to classify it into those categories of safety critical, fit, form and function and visual defect. And then from understanding the risk, you're better placed in the later stages when you come to redesign of what you need to do to reduce those risks to an acceptable level. Number three is to establish the root cause. So mistakes happened, and there might be a clear answer as to why it's happened, but I think it's always worth using a technique like the 5 whys to drill down to the root cause of the issue and to find the underlying reasons why it happened this time, and maybe also you'll probably also discover that root cause is causing other mistakes as well. So let's take a quick example. Say an operator fitted the wrong component to a product. So we asked why that happened. Well, they look quite similar and they're in the same place on a production line. So ask why again. Well, maybe it's because they come from the same supplier. And they're placed in the same location by the stores guy when he brings them out to restock the line. Why does he do that? Because that's the quickest way to do that on his route. By drilling down a few levels, we're starting to understand the things we need to do to address the process fully. So in that scenario, just by focusing on the operator who picked the products, isn't really going to resolve the full issue. We need to come up with a solution that also addresses the placement, the picking and the storage of components on the line. So once you are at the root cause, step number 4 is to redesign the process. And there's a few ways of looking at this really. Like the most effective way to design out the mistake would be to use, there's a Japanese term called poka-yoke, which basically means a mistake proof. If you can mistake proof it, it means you're literally designing out the possibility that that mistake can ever happen again. So an example would be with the product, if you could maybe change a thread, so you literally couldn't screw in the wrong component. If that's not possible, maybe the second level down might be to mistake proof the poka-yoke, the tooling, or the fixture, so that you can't fit, you can't, or it makes it extremely difficult to fit the wrong component in the wrong place. The next level down from that, if poka-yoking isn't really possible, is to put in some kind of visual alert and then immediately afterwards a verification. So in the example before, it would be, you've got two similar products, they have to be interchangeable for some reason. So let's do something visual. So maybe put one component in a green bin, one in a red bin, and then at the point when the operator picks, make sure it's flagged up that he has to use a green component. Another solution to that may be using something like a pick-to-light system, where it lights up, this is the box to pick, and maybe checks that his hand's gone in and broken a light curtain to make sure he's got the right part. That's a good as guidance, but it's not a guarantee. So immediately after that, there should be a verification either by a test or some kind of inspection, or with a camera to make sure that the mistake hasn't occurred. Don't leave it to the end of the production line. That happens, but then the amount of rework that has to happen is really, really costly to strip that product right back, replace the component, and then put it through the manufacturing process again. Rework like that can be really disruptive. So putting in a small, quick verification immediately after the process is a much more effective way of addressing that issue. Step number 5, once you've redesigned, is to track your ongoing performance. So from the point that you did and implemented your redesign process, know what your baseline metrics are for things like number of customer returns or through test before it is shipped to a customer, and then start tracking daily, weekly, monthly, whatever. Simply to start off with, just in an Excel spreadsheet's fine, and just make sure that the metric is going in the right direction, that the number of customer returns are coming down for this issue, and that the first through test rate is going up related to this issue. It can give you that justification that, yeah, we spent some time and money redesigning the process. It's being effective because it's saving us so much time at a test and giving us reduced costs in returns from your customer. So you need to make sure you've got those facts to present that it's been effective what you've done. Okay, so let's just quickly summarize. So the steps of how to prevent and detect mistakes in the manufacturing process. Number 1, build a team to address the issue. Number 2, identify the risks of the mistake that you're addressing. Number 3, then drill down to the root cause of what caused the mistake. Number 4 is to redesign the process based around those root causes that you found. And then number 5 is to track the performance of the solution after you've redesigned your process. So hope that was helpful. If you like this video, click like below and subscribe for other updates like this in the future. And then let me know in the comments below which of these steps you think is going to be most useful for you, or do you do something slightly different when you're addressing issues like this. Thanks very much for listening, and see you next time.